So this is the 38th video on rigid body kinematics. Okay, this is in continuation of the 37th video. In this also I'll take up problems on location of IC. Before going ahead, I will repeat that all the videos have been put on this chapter has been put in the playlist on rigid body kinematics. You can go and see all of them. And if you understand all this, then you don't have to go anywhere else. It's sufficient from all point of view. You just take up numericals. You'll be able to solve most of them. In case you have difficulty, you write the difficulty in the comment box. I'll look into it. Fine. So this also will take up problems on IC location. But before I go ahead, one thing I'd like to say. Suppose we have a rotating rigid body M. Suppose we have a rotating rigid body M. And suppose F1 and F2 are two frames. M undergoes plane motion with respect to F1, F2 both. Location of IC depends on the frame of observation. Okay. That is, IC of M with respect to F will not coincide with the IC of M with respect to F2. This point has to be cleared. Okay. That is, IC of a rotating body depends on the frame in which that rotating body is being observed. Okay. So location of IC is frame dependent. Location of IC is frame dependent. Location of IC is what? Frame dependent. That is, location of IC of M as seen from two different frames F1, F2 will not coincide in general. They will in general not be coincident. They will not coincide. Okay. Why so? This is because velocity depends on the frame of reference. Suppose IC of M with respect to F is this point, IC1. This point has zero velocity as seen from F1 by definition of IC. But F2 and F1, there is some relative motion between F2 and F1. This point which has point of M which has zero velocity with respect to F1 did not have zero velocity with respect to F2. With respect to F2, this will have some non-zero velocity. So IC of M with respect to F1 will not coincide with IC of M with respect to F2. Okay. So this means that IC of a rotating body depends on the frame of observation. IC of M with respect to F1 is not also the IC of M with respect to F2 because of relative motion between F1 and F2. So point which is IC with respect to F1 has a non-zero velocity with respect to F2. So this point is IC with respect to F1, but this is not IC with respect to F2. So IC depends on the frame of observation. Alright, this point I have cleared. Okay. Be clear about it. Okay. Now I'll take up another question. A circular drum with center at C and radius R rolls without slip over a translating plank. Over a translating plank as shown. In each case, find the location of IC of drum with respect to first ground G and second with respect to plank, that is P. With respect to ground, that is G, and with respect to plank, that is P. Okay. G meaning ground frame. Okay. So in this, by several methods. By several methods. Okay. By several methods. So first we will take this problem. This is the side view of the drum. C is the center. R is the radius. This is the translating plank. Okay, fine. Now, this is undergoing pure rolling here. Center is moving at a speed of 4v with respect to ground. And plank is moving at a speed of v with respect to ground. And here it is undergoing pure rolling as I mentioned just now. Here we are undergoing pure rolling as we have stated just now. Okay, fine. So now we have to tell We have to locate the IC of the drum with respect to ground and with respect to plank. And we have to specify the location of IC in terms of distance from center C of the drum. Okay, fine. So first we locate the IC of drum with respect to ground. Okay. So IC of drum with respect to ground to be located. That also we do by several different methods. Now this I have, okay. So IC of drum with respect to ground to be evaluated. Okay. Now one thing in this case, if this is undergoing pure rolling over the plank and both the speeds are rightward direction and this is more than this, then omega should be clockwise. Okay. So this is the material point P1 of the plank in contact with material point D1 of the drum. Okay. Now we have to locate the IC of drum with respect to ground. We have to locate the IC of drum with respect to ground. Okay. So what we do, we consider pure rolling here. P1 is the material point of translating plank. Velocity of plank is V. So velocity of P1 with respect to ground is also V rightward. Here it's undergoing pure rolling. So D1 and P1 will have the same velocity in ground frame. So velocity of D1 is also V rightward. So this is the center C. This is the point D1. Okay. Fine. Okay. Now C has a velocity of 4 V with respect to ground. And D1 has a velocity of how much? V with respect to ground. Pure rolling criteria. Now see, this point D1 is moving rightward at speed V. Center C is moving rightward at speed 4V. If we take any point P here at a distance R from center C, so P dash C, P dash, then velocity of P dash will be a continuous function of R. Okay. So at when R is 0, that is when P dash is C, velocity is 4V, right? And when R is equal to capital R, that is P dash is D1, velocity is rightward. So the point which will have 0 velocity with respect to ground will lie somewhere below this D1. See, here it is 4V right, here it is V right. 0 point velocity of 0 point of drum with 0 velocity should be below D1. Point of drum with 0 velocity should be below D1. So IC of drum with respect to ground should be somewhere here. Now we have to find the distance of IC from center C of the drum. Let us call it Y say. Now we can evaluate Y by several ways. For example, we can do this. What is the distance of center C from IC? Y. The speed, angular speed of drum with respect to ground is omega. From IC concept, speed of center C is equal to 4V, that is equal to omega Y. Omega Y is equal to 4V. And speed of D1 from IC is how much? This distance is Y1 minus 2R. This is 2R. This is, sorry, R. This is R. This is Y. So this is Y1 minus R. So velocity of D1 is V barabar omega into Y1 minus R. Omega Y is 4V. And omega into Y1 minus, Y. This will be Y, sorry. Y omega into Y minus R. Y minus R will be equal to V. Now if we divide these two equations, then what do we get? 4V by V is omega Y by omega into Y minus R. Omega cancels out. Y by Y minus R. 4V by V becomes 4. So Y becomes 4Y minus 4R. So Y becomes 4R by 3. 4R by 3 below point D1. That is the required answer. So this we obtained by method 1. Now we can also solve this by method 2. Method 2 is this. We first what we do, we find the angular speed of drum with respect to ground. That is same as the angular speed of line CD1. So line CD1 is this one. This is C. This is D1. C1 has a velocity of 4V rightward. D1 has a velocity of V rightward. So omega is equal to relative normal speed by separation. Normal speed of C is what? 4V right. Normal speed of D1 is what? V right. Both are in same direction. So from theory of relative velocity between two moving points, relative normal speed becomes 4V minus V and separation is simply capital R, that is 3V by R. Okay. So now this I'll rub it, okay. So G, omega equal to 3v by r. Now suppose distance of IC from C is y. So velocity of C will be equal to omega y. Omega y is equal to 4v and omega is 3v by r. So this implies 3v by r into y is equal to 4v. V and v cancels out. Y becomes 4r by 3. Same answer as you obtained by method 1. Okay. Alright. This we can solve by one more method. Method 3 also. How we solve it by method 3? How? We solve it by method 3 in this way. IC of drum is at a distance of Vc by omega from C along the direction omega cross Vc. Along the direction what? Omega cross Vc. This are a bit okay. Along the direction omega cross Vc. Now Vc by omega is how much? Vc is just given to be 4v and omega we have calculated in method 2 how much? 3v by r. So v cancels out, this becomes 4r by 3. Along which direction? Along the direction omega cross Vc. Now omega is clockwise as you can see. Clockwise sense meaning omega is direction of omega is cross normally into the plane of board. And Vc is what? 4v rightward. So omega cross Vc becomes how? Omega is this way, Vc is right, omega cross Vc is downward. So 4r by 3 vertically below C. Same answer as you obtained in method 1 and method 2. Okay. And method 4 what do we do? IC of drum is at a distance of Vd1 by omega from C along the direction omega cross Vd1. Along the direction what? Omega cross Vd1. Okay. Now Vd1 by V. Vd1 is how much? Vd1 is V. Omega is how much? 3v by r. That becomes r by 3. R by 3 from d1. Okay. Now in which direction? Along the direction omega cross Vd1. Now Vd1 is what? This side. Vd1 is rightward. And omega is what? Omega is clockwise. Omega is inward. Clockwise omega. Omega direction omega is cross. Normally into a plane of board. Vd1 is rightward. So omega cross Vd1 is downward direction. So IC of the drum with respect to ground is at a distance of r by 3 below d1. That is at a distance of r plus r by 3 below C. That is at a distance of 4r by 3 below C. At a distance of 4r by 3 below C. Okay. At a distance of 4r by 3 below C. Same answer as you obtained by first three methods. Alright, fine. This is a bit okay. Now what we have to do, in the first part of the question, we located the IC of drum with respect to ground by different methods. Now what we'll do, we locate the IC of drum with respect to ground with respect to plank. That also has several different methods. Now we have located the IC of drum with respect to ground. Now we locate the IC of drum with respect to plank by several methods. This is a bit okay. This is part B of the question. This is again the drum. This is the translating plank. Plank is moving rightward at a constant speed v. Center C rightward. C moves at a constant speed, constant 4v with respect to ground. This is also v with respect to ground. This is omega, clockwise omega. Here pure rolling is taking place. Pure rolling. Now we have to locate the IC of drum with respect to plank by several methods. So let M1, method 1. Now method 1 is by observation. Method 1 is by mere observation. A mere observation, method 1 we can apply. Now see, D1 is the material point of the drum and P1 is the material point of the plank. Both are in contact. Now here pure rolling is taking place. Now in the P1 is the material point of the plank. So velocity of P1 with respect to plank is 0. Of P1 with respect to plank is 0. Velocity of P1 with respect to plank is what? 0. Because P1 is the material point of the rigid plank. Now here pure rolling is taking place. So from pure rolling criteria, D1 and P1 should have the same velocity with respect to plank. But velocity of P1 with respect to plank is 0. So velocity of D1 with respect to plank, that should also be 0. So with respect to plank, velocity of material point D1 of the drum is 0. So by definition, D1 is the IC of drum with respect to plank. So velocity IC of drum with respect to plank is at a point D1. That is at distance R vertically below C. First answer we have obtained by method 1. Okay. Method 2. Method 2, what do we do? See. Method 2, this is what we do. See. Method 2, what we do? We apply SRC method, okay, by IC concept. This is C, this is D1, okay. Now method 2, what we do first? We find the velocity of center C of drum with respect to plank and velocity of D1 with respect to plank. Now as I mentioned just in method 1, velocity of D1 with respect to plank is what? That is 0. And velocity of C with respect to plank is what? VCP means what? Velocity of center C of drum with respect to plank. Okay. Now, see, when we are determining we are applying SRC procedure, when we are determining IC by plank in plank frame, all the velocities and angular velocities have to be taken with respect to plank frame. In the previous, when we determined the IC of drum with respect to ground, all the velocities and angular velocities was with respect to ground. Now when we are determining the IC of drum with respect to plank, all the velocities and angular velocities have to be taken with respect to plank. So first what we should do, we should first find the velocity of C and D1, material point C and D1 of drum with respect to plank. First we determine the velocity of center C of drum with respect to plank. Now plank is translating with respect to ground. So VCG from the theory of translating frame is equal to VCP plus VPG. Alright. So VCG becomes VCP plus VPG. Alright. Now VCG is what? 4V rightward given. VCP we have to determine. And VPG is what? VPG is simply velocity of plank with respect to ground, that is V rightward. So velocity of center with respect to plank becomes 3V rightward. And velocity of D1 with respect to plank is 0 as I mentioned in method 1. Okay, fine. Now see, this is C, this is D1. Okay, velocity of center with respect to plank is 3V rightward and velocity of D1 with respect to plank is 0. This is the distance R. Okay, now we also have to determine the omega of drum with respect to plank. Now we know omega of drum with respect to ground is omega of drum with respect to plank plus omega of plank with respect to ground. But omega of drum with respect to ground is simply omega as specified in the problem clockwise. Omega of drum with respect to plank we have to determine, and omega of plank with respect to ground. Now plank is translating with respect to ground, it has no rotation. So for 0 rotation, angular velocity becomes 0. So omega of drum with respect to plank is also omega, same as we determined in method in ground frame. So omega of drum with respect to plank is omega clockwise, as it was omega of drum with respect to ground, omega clockwise. So omega of drum with respect to plank is also omega clockwise. Alright, fine. So omega of drum with respect to plank is also what? Omega clockwise. Alright, fine. So now we have to determine the IC of drum with respect to plank. Now you can see by definition this is the 0 velocity point. So there is nothing to be done here. I think you have to calculate ahead because this point is 0 velocity with respect to plank by mere observation. This is the IC. So there is nothing to be done in this method 2. Okay. Now this error bit, okay. solve by method 3 also. We'll use these concepts. Method 3. Method 3, what we do is this. Method 3, what we do, we first find omega of drum with respect to ground. That we have already found. Omega of drum with respect to ground was how much? As we did in part A of this question. That was 4V minus V by R. 3V by R in clockwise sense. That was omega. That is also the omega of drum with respect to Planck. So now IC of drum with respect to Planck is at a distance of VCP by omega. VCP means the velocity of center of drum with respect to Planck. That is equal to, that is along the direction omega cross VCP. Along the direction of omega cross what? VCP. Now VCP by omega is how much? VCP we know how much it is, 3V. And omega is also what? 3V by R. That is just equal to R. Along the direction of omega cross VCP. Now since omega is what? Clockwise. So direction omega is cross. By the right hand thumb rule, omega is directed into the plane of board. And VCP is also rightward. So omega cross VCP is downward. So IC is at a distance of R below center C. R below center what? C. That is at point D1. At point which one? D1. Okay. So both the ICs have been determined. Okay. First we determined the IC of drum with respect to ground by several methods. Then we determined the IC of drum with respect to Planck by several different methods. One was by mere observation, and second was that also by mere observation only. And this also, M3 was also by using that concept. Okay. So in all cases we get the same answer that we should get. Fine. All right. Now this side of it. Okay. So now I take another question. Next question I take up. So again, this is a drum. This is a drum, circular drum, side view, center C, radius R. Center moves rightward at a speed say V with respect to ground. And this moves at a speed of 5V with respect to ground. And here pure rolling is taking place. Pure rolling takes place here. And omega of drum with respect to ground is like this omega with respect to ground. Again in this case, this is the side view of the drum. We have to locate the IC of drum with respect to ground and IC of drum with respect to Planck. That we have to determine, okay? We have to locate the IC of drum with respect to Planck, with respect to ground, and IC of drum with respect to Planck by several different methods. And here, this is the material point D1 of the drum in contact with material point P1 of the Planck. And Planck we are denoted by P. P is the Planck, alright? Again, what we have to do in this case, that I have already mentioned. Fine. So first, we determine the IC of drum with respect to ground. To locate IC of drum with respect to Planck. To locate the IC of drum with respect to what? Planck. To locate the IC of drum with respect to Planck. Sorry, with respect to ground, sorry. First with respect to ground, okay? And then with respect to Planck. Now this also is solved by methods, different methods. Method 1, M1. So first of all, see, you draw the line CD1. This is center C, this is D1, okay? Now center C is moving at a speed V rightward. Now see, P1 is the material point of rigid Planck. Planck is translating at speed 5V. So velocity of P1 with respect to ground is also 5V with rightward. Now here pure rolling is taking place. So from theory of pure rolling, velocity of d1 is also 5v rightward with respect to ground. So d1 is moving at a speed of 5v with respect to ground. Okay. d1 is moving at a speed of how much? 5v with respect to ground. Okay. Now we have to locate the IC of drum with respect to ground. Now one thing you see, in this case, if you take up some point here, velocity of this point will be a linear function of distance y from d1. Now when y is 0, then that is this point is this point. Velocity is 5v rightward. And when y is equal to r, that is y is this point is center, then velocity is rightward. So 0 velocity point should be somewhere above center, somewhere here. That should be the IC of drum with respect to ground. Okay. So let us denote this distance by say y0. Okay. And what the sense of rotation of drum with respect to ground is omega anti-clockwise. So now see, center is at a distance of y0 from IC. Velocity of C will be v, that is equal to omega y0. And d is at a distance of r plus y0. Y0 is this distance and this is r. So d1 is at a distance of r plus y0 from IC. The velocity of d is equal to 5v, that is omega into y0 plus r. Now we divide these two. When we divide these two, 5v by v becomes omega into y0 plus r by omega y0. Omega cancels out, v cancels out. So y0 plus r becomes 5y0. R becomes 4y0. Y0 becomes r by 4. This is the required answer. Okay. So method 1, what we did, we wrote two equations. One for we did for center and one we did for d1. That was method 1. In method 2 we apply a easier method. We first determine omega. We determine omega using the concept of relative normal speed by separation. Now normal speed of C is v right. Normal speed of d1 is 5v right. Both are in the same direction. So relative normal speed will be 5v minus v by separation r. That becomes 4v by r, and that is in clockwise sense. Anti-clockwise sense, sorry. Now IC of drum with respect to ground is at a distance of v by omega from C, is at a distance of v by omega from C along the direction omega cross VC. Now omega is what? Anti-clockwise sense. Anti-clockwise sense meaning omega, direction omega is dot, normally out of plane of board. And VC is what? VC is rightward. So omega is this way, VC is rightward. Right hand, the direction of cross product is upward. So it is equal to distance of v by omega. Omega we have followed 4v by r. That is simply r by 4. R by 4, and along direction of omega cross VC. Omega direction is outward, VC is rightward, omega cross VC is upward. So r by 4 above center C. So same answer is obtained by method 1 also. R by 4. R by 4 above center C. Here also r by 4 above center C. Actually IC is actually r by 4 is inside the body, but I have shown it here. That just to show it, okay. Calculation we get the same answer. Now what we do, this I solved by method 2. Now method 3 also we can solve it. Method 3 also. Method 3, IC is at a distance of v d1 by omega from d1 along the direction omega cross v d1. Now what is v d1 by omega? V d1 is how much? That is 5v. And what is omega? Omega is how much? 4v by r. So this becomes how much? 5r by 4. So direction 5r by 4. That is the IC, distance of IC from P1, D1. Now in which direction? Along the direction omega cross VD1. Omega is what? Omega is anti-clockwise. Direction of VD1 is outward. Sorry, omega is anti-clockwise. Direction of omega is outward. VD1 is rightward. Omega cross VD1 is upward. So 5r by 4 above D1. That is 5r by 4 minus r above C. That is r by 4 above C. Same answer as we obtained. So IC is at a distance of 5r by 4 above D1. That is r by 4 above C. Same answer as you obtained by other methods. Okay. This are a bit, okay. Now we determine by method 3. Third method. Okay. Next method we do, next method, whatever it is, huh? We solve it by next method also. Next method is what? IC of drum with respect to ground is at a distance of I think we have discussed all the methods. Is at a distance of first what I did, that's then I wrote omega. Fine, okay, all right, okay, as a distance of no, this is all right, this is done, this is all right. So this we have discussed, all the methods we have discussed. Okay, this you can cancel it. Okay, remove it. Now what you have to do now is you have to locate the IC of drum with respect to Planck by several methods. To locate the IC of drum with respect to Planck, okay, by several methods. Now, if you have to locate the IC of drum with respect to ground, then all the velocities and angular velocities must be with respect to ground. If you have to locate the IC of drum with respect to Planck, then all the velocities and angular velocities must be with respect to Planck. So first what we should do, we should determine the velocity of C and D1 of drum with respect to Planck and omega of drum with respect to Planck. Okay. So first we determine the velocity of center C of drum with respect to Planck. So we write on the translating frame formula because Planck translates with respect to ground. VCG is equal to VCP plus VPG. So this means VCP is equal to VCG minus VPG. Now this becomes VCG plus reverse of VPG, that is minus VPG. Now VCG is what? VCG is V right. And minus VPG is what? VPG is 5V right. Minus VPG is what? 5V left. So vectors of these two will be 4V left. Okay. And similarly velocity of D1 with respect to Planck, that will be what? That will simply be velocity of D1 with respect to Planck. Okay. So that will velocity of D1 with respect to Planck is simply what? Tell me. Again we write similarly, write down the equation. Velocity of D1 with respect to ground, velocity of D1 with respect to Planck plus velocity of Planck with respect to ground. Velocity of D1 with respect to ground from pure rolling criteria is 5V right, as we discussed just now. Because pure rolling is taking place, P1 is having a velocity of 5V right, velocity of D1 is also 5V right with respect to ground. V D1P and velocity of Planck with respect to ground is also 5V right. So from this we see that velocity of D1 with respect to Planck is simply 5V minus 5V, that is 0. So from here itself we get that D1 is the IC of drum with respect to Planck. D1 is the IC of drum with respect to Planck because it has a 0 velocity with respect to Planck. That is just IC here. So we don't have to do anything beyond this in this. Okay, so one method we have already determined. From this method itself we have obtained that D1 is the IC of drum with respect to Planck. Okay, so this we have obtained here direct. This are a bit, okay. But this formula itself we have obtained the answer. Okay. And one more thing, omega of drum with respect to Planck is how? Omega of drum with respect to ground is equal to omega of drum with respect to Planck plus omega of Planck with respect to ground. Omega of drum with respect to ground is omega anti-clockwise. Omega of drum with respect to Planck we have to determine, and omega of Planck with respect to ground is 0. Why? Because Planck is translating with respect to ground. So translating body has 0 angular velocity. Omega BPG becomes 0. So this means omega of drum with respect to Planck is omega anti-clockwise, same as omega of drum with respect to ground. As we just now calculated how much? 4V by R anti-clockwise. Okay, so omega of drum with respect to Planck is 4V by R anti-clockwise. So omega of drum with respect to Planck is 4V by R into anti-clockwise sense. Okay, so now what we do, we determine by different methods. So we apply this method. IC of drum with respect to Planck is at a distance of VCP by omega along the direction omega dp cross VCP. Now VCP by omega is how much? VCP is what? Velocity of center with respect to Planck. That is just 4V left. And omega dp is simply 4V by R. So this simply becomes R. It is at a distance of R. Along which direction? Omega dp cross VCP. Now omega dp is what? Angular velocity of drum with respect to Planck. That is same as omega of drum with respect to ground. That is what? Anti-clockwise sense. That is direction what? Dot. And VCP is what? VCP is rightward. So omega dp is outward, VCP is rightward. So this becomes cross product. So omega cross VCP. VCP is what? VCP is 4V left and omega dp is dot. So omega dp outside, 4V right side. Omega dp cross VCP is downward direction. So IC of drum with respect to Planck is at a distance of R below center C. That is the point D1. So IC of drum with respect to Planck is nothing but the point D1 itself. Okay. IC of drum with respect to Planck is nothing but the point D1 itself. Alright, fine. This also I have fully explained. Alright, fine. So this was the 38th session on rigid body kinematics. Okay. I'll take up one more problem on this one. Okay. This are a bit, okay. I'll take up one more problem on this concept. See again, this is a similar situation. This is a drum. This is a translating Planck. Planck moves at a speed v with respect to ground, translating Planck. This is a Planck. This is a drum, C center, R radius. D1 is the material point of drum in contact with material point P1 of Planck at the given instant. Center is moving at a speed of 7v with respect to ground. And here pure rolling is taking place omega. Here pure rolling takes place. Here pure rolling takes place. Now we have to determine the IC of drum with respect to ground and IC of drum with respect to Planck. So first we'll determine IC of drum with respect to ground. This we have to determine first. IC of drum with respect to ground. Now this also will solve by different methods. Okay. So method 1. Method 1 is this. See. Center of drum is moving leftward at a speed 7v. P1 is the material point of translating Planck. So velocity of P1 is same as 4v rightward. Here pure rolling takes place. So velocity of D1 with respect to ground is same as velocity of P1 with respect to ground, that is v rightward. So D1 also moves at a speed of v rightward and center C moves at a speed of 7v leftward. Okay. Now you draw this line joining C and D1. Now see, center C is moving left and D1 is moving right. If you take any point P on this line, say at it is P dash, on this line at distance say y dash from C, then when y dash is 0, then P dash is C, velocity is leftward. When y dash is R, P dash is D1, velocity is rightward. So since Vp dash is a continuous function of y dash, there should be a point P dash lying on this line segment CD1 where velocity of P dash becomes 0. By definition, that is the IC of the drum with respect to ground. So in this case, IC of drum with respect to ground will lie somewhere on this line segment CD1. Let us call this distance as say y. Okay. Now what we do, center is at distance y from IC. Okay. So we'll write 7v equal to what? Omega y. And d1 is what distance? This is r, this is y, so this is r minus y. So v d1 is simply v rightward, that is omega into r minus y. Now we divide these two. When you divide these two, 7v by v becomes omega y by omega into r minus y. Omega cancels out. 7 is equal to y by r minus y. So 7r minus 7y is equal to y. 7r is equal to 8y. So y is equal to 7r by 8. So it is the distance of IC from center C. It is 7r by 8 distance vertically below center C. This is therefore the required answer. Okay. So IC of drum with respect to ground is at a distance of 7r by 8 below center C. One method we obtained. Now method 2 what we do see. Method 1 what we did, we wrote down two equations. One this and this. In method 2 what we'll do, we'll first find omega. Omega is again what? Relative normal speed by separation. C is moving 7v left, D is moving v right. So relative normal speed by separation becomes what? 7v plus v by r, that is equal to 8v by r. The sense of this will be anti-clockwise. This is going left, this is going right. So sense of omega will be anti-clockwise. Okay. Now center is at a distance y from IC. Velocity of C is what? 7v. That is equal to omega y. So that means 7v is equal to omega. Omega is simply 8v by r into y. Okay. V cancels out. Y becomes 7r by 8. Same answer as we obtained in method 1. Okay. Now method 3 what do you do? How to solve into method 3? That is the question. How to solve this problem by method 3 is the required question. Method 3. How we solve this problem by method 3? That is the required question. Okay, method 3. So method 3 is this. IC of drum with respect to ground is at a distance VCG by omega along the direction omega cross VCG. Along the direction what? Omega cross VCG. Now this are a bit okay. So VCG is how much? VCG is 7v left. And omega is how much? 7r by 8. Omega is how much? Omega was 8v by r. As we determined just now. That becomes 7r by 8. 7r by 8 distance away from VCG. But in which direction? Along direction of omega cross VCG. Now VCG is which direction? VCG is leftward direction. Is it alright? VCG is which direction? Leftward direction. Omega is what? Anti-clockwise sense. Direction omega is outward, VCG is leftward. So omega is this, VCG is this, omega VCG is below. So 7r by 8 below C. Same answer we have obtained. Same answer as we obtained by method 3. Method 2. Okay. Now finally method 4. IC of drum with respect to ground is at a distance of VD1G by omega along the direction of omega cross VD1G. Along the direction of omega cross VD1G. Now VD1G is how much? VD1G is simply V. V by omega. And omega is what? 8V by R. that is r by 8. R by 8 distance from VD1, that is IC of drum with respect to ground. But in which direction? Along direction of omega cross VD1G. Now direction omega is what? Dot outward. VD1G is rightward. So omega cross VD1G becomes upward. So R by 8 above D1, that is R minus R by 8, 7R by 8 below C. Same answer again. Okay. So we obtained the same answer again. We obtained the same answer again. Alright, fine. So IC of drum with respect to ground is at a distance of 7R by 8 below center C. So this we obtained by several different methods. Alright. So now I rub this one. Now B, what we have to do? We have to determine IC of drum with respect to plank by several methods. Okay. Method 1 is just by method of observation. Method of observation is what? This is this. I draw the diagram again. See, this is the drum, this is the plank. This is the drum, this is the plank. This is the material point P1 of plank. This is the material point D1 of drum. Both are in contact. Here pure rolling is taking place. Velocity of P1 with respect to plank is 0. Since pure rolling takes place here, velocity of D1 with respect to plank is also 0. So by definition, D1 is the IC of drum with respect to plank. So one answer we have obtained. IC of drum with respect to what? Plank. This is the one answer which we have obtained already. IC of drum with respect to what? Plank. Fine. Okay. This also a bit. Okay. Now we want to determine it by another method also. First answer we have obtained by method 1. Now we determine this by method 2. Now IC of drum with respect to plank is at a distance of VCP by omega dp along the direction of omega dp cross VCP. Alright. Omega dp cross kya? What? Omega VCP. Now this side of this one, okay? Now VCP, we have to determine VCP and omega dp. VCP meaning what? Velocity of center with respect to plank P. So how to determine VCP? We apply the formula for translating frames. VCG is equal to VCP plus VPG. So this means VCP is equal to VCG minus VPG. Now VCG is what? VCG is 7V left and VPG is what? V right. So minus VPG is what? V left. And 7V is also 7V left. Vector sum of these two will be 8V left. Velocity of C with respect to plank becomes 8V left. Now we need omega of drum with respect to plank. So we write down the formula. Omega dg is omega dp plus omega pg. Now omega pg is 0 because plank translates with respect to ground. No rotation, so 0 angular velocity. Omega of drum with respect to ground is omega. So omega of drum with respect to plank is also omega. Omega of drum with respect to plank is also what? Omega. Alright. But omega of drum with respect to ground we have determined already. How much is it? 8V by R. Okay, fine. So I'll write here, okay. So IC of drum with respect to plank is at a distance of VCP by omega dp. Now VCP by omega dp becomes what? VCP is how much? VCP is 8V. Omega dp is what? 8V by R. That is R. R distance along the direction omega dp cross VCP. Now omega dp is anti-clockwise sense. So direction of omega dp is dot, normally out. And VCP, velocity of center with respect to plank, is left, 8V left. Omega dp is outside, VDP is left, omega cross VDP is below. r distance below center C, that is at point D1. Same answer again we have obtained. Okay, so again we have obtained the same answer as we obtained by remaining methods. Alright, this was one of the major chapters on rigid body kinematics. Still some more videos have to be made on this chapter, and then this rigid body kinematics will then be finished. Okay, so go through it properly. If you have any doubt, write in the comment box. I will look into it. Okay, and all these videos have been put in the playlist of rigid body kinematics. Alright, so I close it here. Fine.